Hello, my name is Joe Camioni, and I would like to demonstrate a hobby motor design based on a Nikola Tesla patent. I want to demonstrate to you how more powerful this motor design is. This is a conventional Edison-style electric motor, DC hobby motor. I'll go over the basic design feature. There's one set of brushes in this motor, and here's the armature and the commutator. Okay, so in this style motor there is one continuous wire that's wrapped around all the different poles of the armature. As an individual, so it uses the path of least resistance feature to energize any given pole. The resistance of this pole being energized, for instance, with the one wire going around continuously to each commutator. It's all one continuous wire, so it's going to be 5 times the distance, being 5 poles, or 4 times the distance. You got one wire length for the primary coil that's energized as it rotates through its different poles of the magnets here as it's energized, and the path of the rest of the wire is going to be 4 times longer than the primary, so it'll have least resistance, and then most of the current is going through this one direction. But as it rolls off the commutator, you get an effect that's known as counter EMF. As we have, this is a coil, and it does not like to be de-energized once it's energized. So it will try to keep the current flowing as it rolls off the commutator and becomes disconnected. And so since it's all one wire, this natural force of counter EMF, as the field is collapsing in this one pole that's rolling off the commutator, it would generate what's known as a counter EMF. In any Edison style motor, here I have a diagram, we're going to run some tests at this point here. Maximum speed, no load. And so we're not really able to do any power. Power goes to 0 at that point. So what you have is all the electromotive energy is being used to generate the RPM is sped up to its maximum speed, where all the electromotive force that you're putting in is balanced by friction and counter EMF. So that, and now with the Tesla style motor, here's his patent where he covers it. This is patent number 390414. Be known that I, Nikola Tesla, have invented certain new and useful improvements in dynamo electric machines, of which this is a specification. Here is one diagram of this improvement is where he uses a dual commutator. Now it's split from the shaft here, and this shaft would go right through the middle there, but there's 2 commutators there. This diagram here is a little better representation. And you can see this is a much larger armature, but you can see the two commutators here in this larger motor to demonstrate it. And that's what's in this motor here. So here's the Edison style motor. We'll run some tests. Okay, I'm going to run them at 9 volts. Okay, and we'll do a, and we'll see we're drawing about 0.6 amps, 0.55, 0.6 amps. And we'll do a test of the RPMs. Unfortunately, it's upside down, so we'll get this here, and we'll do memory, and we get 12,000 RPM. Okay, and about, now it's settling down about 0.55 amps. Okay. Now on this motor here we have dual commutators, so we now have 4 connections, 2 on each side, and so in each coil, I'll read the basic design feature of these. Each coil is wound independently. Having now described my invention, what I claim is combination with the converter having independent energizing coils of a continuous or direct current dynamo or magneto machine and intermediate circuits permanently connected as suitable points to the induced or generating coils of the generator as herein set forth. Okay, so they're independent coils. What this means is, as I said, this design is all one wire. If you unwind this, it's going to be one continuous wire. Each one connects it, and so each coil sees the counter EMF of all the other 4 coils as it rolls off a commutator. But this design is, each coil is independent, as that Nikola Tesla. So this motor is based on this patent of Nikola Tesla, 390414. Each coil is independent. It'll go from this wire commutator to this commutator over here, and there's going to be a series of wraps, you know, as is normal for this style of armature. You'll wrap several poles, and it comes out over here. And so it's impossible for the counter EMF, once it rolls off the commutators here, it's impossible for the counter EMF to fight the motor rotation. The counter EMF fights the motor rotation. So now let's see, this is motor. This is a Radio Shack style 9-volt hobby motors that were available once in the day, as they're bankrupt now. And this motor is built with the exact same components of these motors here. So this means the same strength magnets, and you use a little different wire size than what's provided by the manufacturer in the Edison style motor. You no longer have counter EMF fighting you. So let's hook this up. Now we'll run both. So now we have 2 armatures that are capable of being, or 2 sets of coils that are have potential to be energized, and it gives you an extra boost. We'll hook up one. We go over here, the counter side here. You see it has a little higher pitch to it already. And we'll just run the maximum design, or the maximum configuration where we get the max power. And energize the other coil. I want to use red on red. Do plus, plus, and now we'll energize that other coil. You can hear the RPM picked up a little bit. I gotta put the there. That's the helps for the RPM gauge to detect RPM. And we get 25,000 RPM. So the question is, and we get about 8/10 of a we're getting about 75.75 amps. Okay, so let's do the numbers. Now let's get the amperage again here. I'm not sure if I pointed it out to you before. Let's do the amperage one more time here. It should be around a half an amp, but I'll demonstrate it. You'll be able to see it on this power supply here. Okay, about 6/10 of an amp. So let's now how do we compare the performance of this motor? Well, let's generate a number of thousands of RPM per amp. Let's put the numbers in here. Okay, we had 6/10 of an amp on the Edison style motor, and I had 0.75 amps. And I was getting 25.5 thousand RPM. $25,255. Write my numbers down. And 12,000 RPM and a 6/10 of an amp here. Let's do the numbers. Twelve 12,000 RPM divided by 0.6 amps. I get 20 as the number. Which means I get 20,000 20 thousand RPM per amp. On the Edison style motor. For the Tesla style motor, I do 25.2 was the last number, 0.25, I think it was 25,250 divided by the amperage was 0.75. And I get a number of 33.6 thousand RPM per amp. So this motor outperforms the Edison style motor by a factor of 50%.